And that's absolutely not what happened in my experiment. I have demonstrated with my photo gate the velocities can't be denied. 3 times the velocity produced a linear stretch of a distance very close to 3 times as much.
Okay, so he's still saying that somehow all he has to do is measure the linear distance, that line, and he doesn't have to pay any attention to how much energy is in the rubber band. Just bullshit. Complete bullshit.
And as always, you didn't understand what I was trying to say. So yes, when you pull the rubber band back with 1 centimeter of distance, right, then the total amount of stretch is, well, yeah, 1 unit of total amount of stretch. Then when you pull the rubber band back with 2 centimeters, all right, 2 centimeters, then the total amount of stretch becomes around 4 times as big, indicating it has around 4 times the energy. And then when you pull the rubber band back with 3 centimeters, the total amount of stretch, all right, these sides become around 9 times larger, indicating it has 9 times the energy. Yes, I understand that these lines grow non-linearly, but however, my experiments, or the experiments, prove you wrong directly, because if I did this a couple of times, and in the past I also have done this, when you let a pendulum or a card collide against a rubber band, right, so I did it. I let a pendulum collide with 1 unit of velocity, then the rubber band would be pulled back with 1 centimeter, this distance. It would be pulled back with 1 centimeter, and then I let it drop with twice the velocity. I use my photo gauge so the timings are undeniable, the velocities are undeniable. I let the pendulum drop with twice the velocity, then the rubber band would be pulled back with 2 centimeters. This distance, all right? 2 centimeters, so you say, but if you pull it back with 2 centimeters, it has a total amount of stretch 4 times as big, so 4 times the energy. So I got twice the velocity, twice the amount of this distance, so indicating that twice the velocity has indeed 4 times the stretch, 4 times the energy.
Here are once again the results of the pendulum drops. On the left, you can see the pendulum with 1 unit of velocity. The timing is 0.092 seconds, and the rubber band was pulled backwards to the 2 centimeter mark. On the right is the pendulum, which went 1.95 times faster, so close to twice as fast. The timing is 0.047 seconds, and the rubber band was pulled backwards to the 4 centimeter mark. So the rubber band was pulled backwards twice as much, and again, you say that when the rubber band is pulled backwards twice as much, there is 4 times more total stretch, so 4 times more energy. So yes, the pendulum went twice as fast and had 4 times more energy.
And then when I also did this, I let the pendulum drop with 3 times the velocity, and the rubber band would be pulled back with almost 3 centimeters. It was actually 2.9, so very close to 3 centimeters. And you say, well, 3 centimeters, if you pull it back 3 centimeters, it has 9 times the stretch, 9 times the energy. So I did it 3 times the velocity, so yeah, 9 times the energy. So it proves kinetic energy right.
And once again, on the left you can see the pendulum with 1 unit of velocity. The timing is 0.0177 seconds, and the rubber band was pulled backwards to the 1.7 centimeter mark. On the right is the pendulum, which went 3 times faster. The timing is 0.0059 seconds, and the rubber band was pulled backwards to the 5 centimeter mark. So the rubber band was pulled backwards 2.9 as much, very close to 3 times as much. And again, you say that when the rubber band is pulled backwards 3 times as much, there is 9 times more total stretch, so 9 times more energy. So yes, the pendulum went 3 times as fast and had 9 times more energy.
But you say no. 1 unit of velocity equals 1 unit of energy, twice the velocity, twice the energy, 3 times the velocity, 3 times the energy. All right, so, but my experiment proved when it goes twice as fast, the rubber band is being pulled back with 2 centimeters, and you say that's 4 times the energy, 4 times the total amount of stretch. So, but you say no, twice the velocity, twice the unit of energy. So in order to have twice the amount of total stretch here, you would have to pull back the rubber band less than 2 centimeters. And it gets even worse when you go for the third one. All right, so again, my experiment showed when I let it drop with 3 times the velocity, the rubber band is pulled back with 3 units here, 3 units of distance. But you say, no, well, that's 9 times the amount of stretch, so 9 times the energy. But that can be true because 3 times the velocity is only 3 times the energy. So in order for this to only have 3 times the amount of total stretch, you would have to pull back the rubber band way less than 3 centimeters. So I showed you here, it should only be around 1.9. It should be way less than 3 centimeters. But that's not what the experiments show. The experiments always show that when you let it drop with 3 times the velocity, the rubber band is pulled back with always around 3 centimeters, or three times as much. I can show you this over and over again with real physical proof. Are you going to accept this? No.